Welcome to this episode where we're diving into the critical skill of conduit bending in electrical work. Specifically, we are exploring the nuances of using mechanical benders, a tool that's fundamental for electricians. We'll draw our insights today from a detailed technical guide on mechanical benders.
That's right. Now, conduit bending is more art than science in some ways, but mechanical benders bring a necessary precision and efficiency to the process. They allow for consistent, repeatable bends, which is crucial on any large project. Unlike bending by hand with hickeys, these allow you to preset the angle and location for quantity bending.
I often hear the term Chicago bender, which sounds quite specific. Is that the official name for these tools, or is it more of a historical reference?
That's a great question. Originally, these devices were indeed called the Chicago bender because the Chicago Equipment and Manufacturing Company first made them. However, today, many different companies produce them, so the correct and more general term is portable mechanical conduit bender. You will still hear Chicago bender on job sites, though, as a common informal name.
So how exactly does a typical mechanical bender work? What makes it distinct from, say, a hand bender or hickey?
Mechanical benders significantly reduce the physical effort needed. You place a length of conduit, secure it, and then pull a long bending handle. For smaller conduits, you might make the bend in one shot, bypassing the ratchet mechanism. But for larger sizes, the ratchet activates, allowing you to make the bend in segments with much less force. They're suitable for conduits up to 2-inch EMT, 1 1/4 inch IMC, and 1 1/4 inch RMC, provided you use the right accessories.
You mentioned accessories. What are bending shoes and follow bars, and how critical are they to the bending process?
Bending shoes and follow bars are absolutely critical. They are precisely designed to form a particular radius for a particular type and size of conduit. Think of them as precision instruments. Any damage to them leads to inaccurate bends, kinks, or other defects. It's essential to always use the correct shoe and follow bar for the conduit you are bending. Using an EMT shoe for RMC, for instance, can damage the tool and ruin your bend.
That makes sense. It highlights the need for meticulousness. What are some of the general tips electricians should keep in mind when working with these benders to ensure accuracy and longevity of the equipment?
There are several key tips. First, an engineer's rule, marked in hundredths of an inch, simplifies formula bending by avoiding fraction conversions. When bending short stub lengths, the shoe can sometimes creep and damage the conduit threads. Screwing a coupling onto the pipe prevents this and protects the threads. When bending offsets, the front of the bender can be temporarily elevated for clearance. Also, bender shoes are often cast aluminum and easily pitted, so keeping the pipe clean and wiped down is crucial for shoe longevity.
What about when you have a short piece of conduit that might not reach the bender's roller or support?
Good point. In that situation, you can slide a larger diameter conduit over the piece being bent to extend its length, or if it's threaded, screw on a coupling with a scrap piece of pipe. Also, for segment and concentric bending of smaller pipes, you can measure from the bend center to the shoe's front on a scrap piece, then use that measurement to adjust your start mark.
It sounds like understanding your specific bender is paramount. The text mentions charting a mechanical bender. What does that involve, and why is it so important?
Charting a bender is vital because the gain and centerline distances can vary between different benders, even of the same type. While benders usually come with charts or decals, these can get damaged or lost. So you can create your own chart using a scrap piece of conduit. This chart will contain crucial data like minimum size, gain, and centerline distances from the bender's arrow to the bend's center for common angles like 15, 30, 45, and 60 degrees.
Can you walk us through the process of charting a bender for those centerline distances?
Certainly. You start by placing a mark, say 10 inches from the end of a scrap conduit. That's your reference. Then you place the bender's take-up arrow on that 10-inch mark. Using a protractor level, you bend the conduit to a specific angle, like 15 degrees. After bending, you remove the bender and use a straight edge to draw two crossing lines across the curve. The intersection of those lines marks the true center of the bend. You then measure the distance from your original 10-inch mark to that center point and record it. You repeat this entire process for 30, 45, and 60-degree bends to complete your centerline chart.
That's very methodical. Beyond centerline distances, what other key measurements do you need to chart?
Next, you determine the minimum rise of the bender, which is the shortest 90-degree stub length it can produce. You place the bender back on the conduit, take up arrow at the 10-inch mark, and bend to 90 degrees. After removing the bender, you measure from the back of the conduit to the 10-inch mark. If that measurement is, for example, 5 inches, then 5 inches is your minimum 90-degree stub length. This number is invaluable for planning accurate stub-ups.
And there's also something called gain. How is that calculated and what does it tell you?
Gain is significant. To calculate it, you make two 90-degree bends on a piece of conduit. You measure the stub length of each bend, add them together, and then subtract the original straight length of the conduit before bending. The difference is the gain. This value tells you how much conduit length is effectively saved because the bend follows a radius instead of forming a sharp right angle. Once you have this, your bender is officially charted.
It sounds like charting your bender gives you a deep understanding of its specific characteristics, allowing for much more accurate work.
Precisely. It helps you understand what the manufacturer's marks mean. The minimum rise mark, or take-up, shows how much conduit the bender uses for a 90-degree bend. The star mark is used for back-to-back bends, located 1 Dean distance back from the minimum rise mark. And centerline marks are for aligning the center of bends, especially useful for saddle bends. Knowing all this means you can make accurate bends without guessing.
Let's talk about specific applications. How do you approach bending stub-ups with a mechanical bender?
Stub-ups are common. The key is knowing your bender's deduct value for the specific conduit type and size. While some benders have decals, it is good practice to have backup charts on hand. For example, if you need a 15-inch 90 degrees stub-up with 1-inch rigid conduit and the deduct chart says 11 inches, you subtract that 11 inches from 15, which leaves 4 inches. You'd measure 4 inches from the end of the conduit, make a mark, and align that mark with the bender hook. Engage the ratchet, bend to 90 degrees using the pointer, and you should have a perfect 15-inch stub-up.
That deduct concept is important. It's not intuitive to measure back from the end for a final height, but it makes sense when you consider the bender's geometry. What about bending offsets?
Offsets are another common bend. Again, the decal chart on the bender, which also has deduct info, will provide data for 20, 30, and 45-degree offset bends. This chart is indispensable for perfect results. Let's say you need a 12-inch offset with half-inch rigid conduit to bypass an air duct. You measure from the conduit's end to the start of the first bend and mark it. Consulting the chart, you might choose two 45-degree bends, and it will tell you the precise distance between those bends. You make the first bend, then slide the conduit through until the second mark aligns, turn the bend over, aligning to prevent doglegs, and make the second 45-degree bend. The height should be exactly 12 inches.
Doglegs are those crooked offsets that don't sit flat, right? How do you really ensure alignment to avoid those?
Exactly. To avoid doglegs, consistency and alignment are paramount. Always use the same angle for both bends of the offset. Ensure the first bend is perfectly aligned with both the conduit and the bender handle. Then, before making the second bend, double-check that alignment again. Tools like a no-dog can help here. It screws onto the conduit and has a built-in level to keep your bends straight. Proper technique means you turn the conduit over and ensure the first bend is visually lined up with where the second bend will be.
So whether it is for stub-ups or offsets, the key really is to understand your bender, rely on accurate charting and measurements, and pay close attention to alignment at every step.
That sums it up perfectly. Precision and familiarity with your tools are essential for producing professional, accurate conduit bends.
Thank you, Eloise, for guiding us through the intricate world of mechanical benders. This has been an incredibly informative discussion.
My pleasure, Noah.
If you found this episode helpful in understanding mechanical conduit bending, please share it with someone who might also benefit.